What is countercurrent mechanism? Countercurrent mechanism is the mechanism of concentration of urine. Till now, we saw the excretion of waste, excretion of GFR and everything. This countercurrent mechanism happens in which nephrons? They happen in the juxtamedullary nephrons, which is around just 15%. But this is very, very essential for the concentration of urine. It is concentrating urine. That's why we are passing around 1.5 liters per day. If this countercurrent mechanism is not in action, how much urine we have to pass per day? We have to pass around 22 liters to 24 liters per day. If we are passing out this much of urine, our only job will be to drink water and go on pee for the entire day, because our entire plasma levels itself is very, very less. There will be severe dehydration. This concentration of urine is such an important thing to happen, and this is done with the help of this mechanism, that is countercurrent mechanism. In this countercurrent mechanism, there are two parts. One is the countercurrent multiplier, wherein the mechanism or the osmolarity or the concentration gradient is created. So our ultimate aim is to create a hyperosmolar medullary interstitium. What is our aim? Our ultimate goal is to create an hyperosmolar medullary interstitium. So it has to be very much hyperosmolarity. Then only it can drag in lots and lots of water. Otherwise, we will not be able to concentrate the urine. Everything will be passed in the urine. Medullary interstitium. So countercurrent multiplier. First thing is it should multiply and somebody has to be there to maintain it. The maintaining part is called as the countercurrent exchanger. So coming to the countercurrent multiplier, which is the most important part involved in countercurrent multiplier, is thick ascending loop of Henle. It is the thick ascending loop of Henle. LOH is loop of Henle. Then the next part which is involved is collecting ducts. Collecting ducts. The third important role of it is descending loop of Henle. Then the fourth one, it is has a very minor role which is involved in this process, is thin ascending loop of Henle. It is not that much important, but this is also involved in countercurrent multiplier. Whereas coming to the countercurrent exchanger, there is only one thing that is involved here, that is Vasa recta. So they will ask you two different types of questions. One question they will ask, all of the following are involved in countercurrent mechanism except. They will give you some different four options. In those four options, the most important ones are these three. They will give all of them are involved in countercurrent mechanism. When the exception is this one, go for thin ascending loop of Henle when they ask countercurrent mechanism. All are involved in countercurrent mechanism except if they ask, then go for thin ascending loop of Henle, because that is the least important. But they will ask you one more question. All of the mechanisms are involved in countercurrent multiplier. This is mechanism. Second question is multiplier. Then what will be our answer? In the option they will give Vasa recta. Vasa recta is not a multiplier. Vasa recta is just an exchanger. So our option will be Vasa recta for the same different question. A little different question. Countercurrent mechanism is the entire process wherein Vasa recta's role is very important. But in a multiplier, Vasa recta is not involved at all. In a multiplier, Vasa recta is not involved at all. So that is the key to note here. So now coming to some facts. What is the most important channel involved in this mechanism? All of us know which is the channel is present in TAL. This is such an important channel. It is involved in various mechanisms and it is involved in countercurrent multiplier also. So the important channel involved here is NKCC. NKCC. Then they will ask which ion is contributing maximum. Which ion? Single ion. They will ask you which single ion is contributing maximum. Here the answer is urea. Where does urea come from? Like how does the urea become the answer here? All of us think that since this is this channel, it should be contributed by sodium or it should be contributed by chloride. But the funny thing is the normal maximum hyperosmolarity created in humans is 1200 milliosmoles. Out of that, half, like more than 50% is also created by NKCC. But when you talk about an individual ion, it gets split up between sodium and potassium. So sodium will be contributing 300, chloride will be contributing 300. That's why we are written 300 milliosmoles each. They are not contributing entire 600. If they give you an option of sodium chloride channel itself or sodium chloride both, then go in for that because they are the most important ions together. But as a single ion, even urea can contribute this 550 to 600 milliosmoles. That's why urea becomes a single dominant ion here and the answer becomes urea. So now coming to this mechanism, how this countercurrent is generated. Countercurrent is our ultimate aim is to make this medullary interstitium hyperosmolar. The end point is here. It has to be made like this. So arbitrarily they are thinking how this potential was generated. It is present already in this stage only. In humans, when you go and do an experiment, this is present, the last one is present already. But now we are trying to establish how this mechanism could have happened and how the medullary interstitium has become hyperosmolar. It is because suppose if the descending loop of Henle and this is the thick ascending loop of Henle, everywhere it should have started with an isotonicity because it is taken from the plasma and it would have started with an isotonicity. But what will happen? Slowly they are trying to concentrate this membrane. What happens here is the NKCC channel is important. The sodium chloride is being reabsorbed constantly and they can create a concentration difference of 200 milliosmoles. For example, everywhere it was 300, what it can do is it can create a difference between them of 200. Now what they can do is they can put 400 here, they can reabsorb and make this 400 and this becomes 200. But this 200 is constantly passed out and new fluid is entering. Now the new fluid is having 300. Now they will try to create a difference of 200. So what will happen? It will become 450 and 250. So this 250 is also passed. Then what will happen? This side also starting to become hyperosmolar. How this is happening? What is the property of descending loop of Henle? Its property is to give water. So its surrounding has become hyperosmolar. So what it will do is it will send the water from here. When it sends the water from here, this osmolarity concentration also increases. Now what will happen? This 400 will come and reach here at some point of time. So it will create the difference like 600, 400. That is the rule here. The difference should be always 200. It can drive the difference always 200. That is the capacity of a sodium NKCC channel. That is the sodium potassium chloride channel. Here NC is important. Sodium and chloride channel is important. So it keeps on happening. The concentration gradient keeps on happening. And finally, they will attain a stage where this channel is completely saturated. So that stage is attained when all of them has become hyperosmolar, which is around 1200 milliosmol. The tip of the loop of Henle also become 1200, whereas the superficial layer might have lesser, but whenever any fluid comes down here, they become concentrated because of its hyperosmolar ability. They will drag in water, more and more water, and they will concentrate themselves and cause the hyperosmolarity. Then coming to the countercurrent exchanger, this is how the multiplication happens. These steps we have not repeated because if you do the same 4 steps again and again, finally it will end up here. One side it is solute is reabsorbed and one side water is also coming in. So this becomes hyperosmolar, the center also becomes hyperosmolar. So this keeps on happening and finally creates a countercurrent multiplier. Then coming to the countercurrent exchanger. This countercurrent mechanism, whichever is created, it should have a blood supply also. So whenever a blood vessel is happening, it should not wash away the solutes. So if normally what happens is if a membrane is having hyperosmolar and it is having a blood supply, what will happen? This blood will start to suck in this hyperosmolar solutions and decrease the hyperosmolarity membrane. We don't want this to happen. So the Vasa recta is a special type of tubes which runs always parallel to that of the countercurrent loop of Henle, which runs always parallel to the loop of Henle. So it is always running parallel to the loop of Henle. So what happens here? On one limb, whenever it goes, it drags in the solutes and reduces the osmolarity. But on the other side, what will happen is, since the osmolarity is reducing, on the other limb, it will be putting back the solutes inside back to it. So it is like exchanging it. It is not doing anything. It is not creating anything. It is just exchanging the osmolarity from one arm to the other arm. That's why they say it does not develop any osmolarity. It just maintains it or exchanges it. So this is all about our counter current mechanism.